Hi there, it's me again, Lindsey. Today we are still not going to explore any mathematical concept, but still a particular problem. Now, where's the problem from? Well, this problem is also from Singapore Math Intensive Practice 3B. Let's see if we have a way to solve it. Now, here is the problem. Problem 1 from the Take the Challenge section of topic 7, which is time. Let's see if we can solve it in the best method and use our own way of solving it. Or maybe the best way. Let's go. Here, let's read the problem first. Grim brought a clock from Optime Clock Company. The clock loses 15 minutes every hour. In other words, it is 15 minutes slow. If Grim adjusts the clock and it reads the correct time at 12 noon today, what time will it read when the actual time is 6 p.m. in the evening? We've read this problem and kind of know some hints and some complicated stuff. How do we solve it? Hint: make a table to organize the data. Yeah, that will be what we do first. Let's keep going. First, let's try to circle the important information here. And first, this important information is pretty important, is 15 minutes slow. Which one is the next important one? Well, yeah, this will be 12 noon. 12 noon is important. And the correct time is important too. Because what if 12 noon is incorrect? Well, that will give us a complete different answer. Another one that is pretty important is 6 p.m. Because we want to know where does it ask us and make a table to organize the data. Now let's scroll down a little bit here. Maybe we should just think about this. We should finish the graph they are making over here. At 12 noon, the actual time will just go, let's just go hour by hour. So this is going to be 2 p.m., 3 p.m., 4 p.m., 5 p.m., 6 p.m. Now we see that Brent's time is always 15 minutes slow than his normal time. But is it just going to be 5:45 or 6 p.m.? Well, no, because we need to slow 15 minutes every hour. That means that we can simplify into 1 hour minus 15 minutes, which is equal to 45 minutes, will be the addition. Now we're just going to add 45 minutes instead of 1 hour. So this is the way to make it 15 minutes slow every hour. Now let's keep going. This feels pretty complicated of adding 45 minutes. But here's another thing. Minutes slower. Because the minutes slower section is just multiples of 15. Then we can try to solve this. Now, here, minutes slower is 0 and then 15. So this is kind of like 0 times 15, then 1 times 15, then 2 times 15, and so on. So 2 times 15 is going to be 30. 30, and then it's going to be 3 times 15, which is 45. And then keep going, it's 60 here. 60. Keep going, 75, 75. And then, let's see. This is 12, 1, 2, 3, 4, 5. And then we just add another one. 15, 90. Here we go. We can use 6 p.m. minus 90 minutes, which is 1 hour and 30 minutes. Now 6 p.m. minus 1 hour is 5 p.m. as we know it. And then we just minus the 30 minutes, which is 4:30. 4:30. But wait, is this really the best way of solving this? Well, actually, this is not really the best way because we're just trying from 1 p.m., 2 p.m., and then doing the minutes slower. This will be way slow. Let's try another way that will it's pretty kind of like, but we don't really care about what 2, 3, 4, or 5 p.m. does. We just care about the first ones. We keep going. Let's see. Here, we can do something else to make it quicker. And the way is to do this. You see, 12 noon to 6 p.m. If I scroll up here, it's going to be 6 hours. And then this will be 12 noon. And that's going to go 6 hours to 6 p.m. This will go 6 hours. 6 hours later, it will be 6 p.m. This 6 hours, it loses 50 minutes every hour. That means it is going to be 15 times 6. Because 15 times 6 is the number of minutes it loses. And 15 times 6 is going to be 10 plus 5 times 6. 15 times 6 equals to 10 plus 5 times 6, which is equals to 60 plus 30, which is pretty easy already. Now we have 90. And this is the same as last time, where we also got 90 minutes from doing the minutes slower one by one. But is this really faster? So we keep going. Now we have 90, and then we subtract it from 6 p.m. Now we can draw a line here, like a timeline. 6 p.m. And then we go back 90 minutes. We go back 90 minutes, and this will get us back to first we get 1 hour, which leads us to 5 p.m. and then 30 minutes, 4:30 p.m. Oops. Should we keep going? Yeah. Well, 4:30 p.m. might be the answer to this very complicated problem. So maybe we should try 4:30 p.m. 4:30 p.m. Let's say that we already have the correct answer, but let's use our method into a harder problem, which is pretty like. One change here. So this 6 p.m. in the evening turns into 10 p.m. which is different. Now, if this is 10 p.m., we do the same method. First, 10 hours. Yeah, that's 10 hours through. And then we use the 15 to times the 10. Now, 15 times 10, which is way easier, is 150. And then 150 minutes. 150 minutes is equal to 2 hours and 30 minutes. And if we have 2 hours and 30 minutes, we should bring it back to our original problem here. 2 hours and 30 minutes. Well, 10 p.m. minus 2 hours is 8 p.m. And that 8 p.m. minus 30 minutes, which is 7:30 p.m. Now, this is 7:30 p.m. here. 7:30 p.m. Okay, that's all for today. Thanks for watching. Bye!